Okay, welcome to the January 22nd, 2018 version of MicroObservatory Mondays for the Youth Astronet community. Today, we're going to have some refreshers on some basic elements of Youth Astronet. And I wanted to start with just reminding what our research has shown works, the particular ingredients of Youth Astronet that seem to produce positive results for kids. So we'll go over that real quick. We'll then have an image processing refresher, and I'm going to show you some feature of the JS9 image processing software that allows you to choose images that are on the image directory of all the MicroObservatory users. Then we'll look at some curriculum, activities, and resources that we want to make sure that okay, so welcome to those who are joining as we're moving along. Here, we're just started with the agenda, and we'll just move on from there. Erica is monitoring the chat box, so if you have any questions, any technical difficulties, please type those in, and she'll be able to answer any questions as we go along. So I really want to thank you all for, I know those of you who are facilitating right now with students or are about to or finishing up, that you, I know it's extra effort to facilitate your students taking these surveys, the pre and post, but that is something that's really important to the National Science Foundation, who's funded this whole effort, and we're bearing fruit from that research because what we've found is that there are several key ingredients of Youth Astronet that produce positive results in students' STEM identity. That's that question where they say, do these people think of you as a scientist, yourself, your teacher, your friends, your family? Positive results in their career interest, their science affinity, interest in computers, engineering, and math, and in the measures, there's not much difference in astronomy knowledge, but here, although we have evidence that students do gain in astronomy knowledge, that's separate from this particular pre-post survey. At any rate, students who report doing more of these things, the chart actually shows the gains of students who report 2 standard deviations more than the average of requesting image with the telescopes, using JS9 to enhance, colorize, and measure images, asking questions, answering questions, and making comments, which we think is the use of the online forums, posting images for others to see, and connecting science to everyday life and to other topics. These specific responses on the post survey correlate with kids who have increases in these measures. So we're really excited to find that. And so what we wanted to do was do some refreshers on those specific activities that prompt those specific tasks by students. So actually, I'm going to go away from my slides for a moment and bring over the Youth Astronet workspace to do some demonstrations, to do a quick refresher of the image processing tool and some new features that you may not be aware have been introduced. So again, this browser-based tool is the same one professional astronomers use. Your students to look at their images are using software that professionals use, and that professionals in lots of different STEM careers use. Image processing is not only important to astronomy, it's important in medical fields, it's important in engineering, important in earth science. All these tools of enhancing images and measuring them are used across many, many STEM fields. So I think you all are familiar with the fact that if you have taken images recently, which I have, I don't know why, I guess these aren't in my list. You will have images in your list, but if you don't, as I don't, you have the archived images to look through, or this link at the top now opens up a pop-up box of the MicroObservatory image directory. So I'm going to click on that link. Oops, and it brings you to this list of all the images that have been taken over the last month. So the web page that opens actually typically has several thousand images on it, and you can see that they start from last night, the 22nd of January. And they go, if I scroll all the way down, they go all the way back to the 20th of December. So it has the last month's worth of thousands of images. And if there's a particular one you're looking for, but you don't have in either the archived image, this is how you use this directory. I'm going to scroll down, and let's say I was interested in M101, the spiral galaxy, and I didn't take that image. Well, I find it here in the list, so I'm going to click on it. And by clicking on it, it brings me to a GIF image in the window of that object, and then the FITS file, which remembers that special format that JS9 opens and that astronomers use. It has that FITS header. So to get that image into my JS9 window, all I have to do is drag the link that ends in .fits and drag it right over above my window. And now I have my image of M101, which doesn't look like much, I have to agree right now, but you'll remember that our key stages to enhancing a really dim image are to use log scaling. It starts to bring out something. Then bring down the high brightness value. I think there's something in there, but I've also enhanced the dark night sky. As I wiggle my cursor around, I look at this pixel value to see what most of the pixels are in the 350s. And I set the low brightness limit at that value, 350. Return. Ah, there's my M101. So, and I can now use these other tools at stretch to really bring that out. Use the color maps, and I can add these images together or find other images all in that pop-up box, which, by the way, is still in my, hopefully in my, in the background here. So if I go back to the directory and I wanted another image, I could find that as well. So that's a really handy link right here on the JS9 window to open up the directory and be able to find any image and explore those images. I want to show you some of the features of the image directory which are useful. That M101 that I just chose, I got to the FITS image by clicking on the file name. But I could also click on this info tab link, and with that I would get some of what's in the FITS header, not the whole FITS header, but I could see, for example, what filter it was. So if I were looking for an RG or B, this is how I'd find out before I dragged it over to my window. And so you can also even see if the weather was decent on the night your image was taken. But anyway, I'm going to hit Command left bracket to go back. I've just gone back. So again, knowing how to get to the image directory is a great way to get lots of images. And an image that I really wanted to call to your attention is we're starting to experiment with identifying targets of opportunity for our YouthAstroNet audience. And over the weekend, Frank, our telescope engineer, put a request for a comet that is currently visible in the queue. And that comet, we haven't been able to figure out a way to actually put it in your request list, but we're working on that within the telescope request page. But the comet's name is C2016, Comet 2016 R2 Pan-STARRS. But if you want to find an object that we announce is a target of opportunity in the directory, if you use the find tool, so I'm going to do Command F, and you see right here, I can look for that C2016, Comet 2016. And you can see here, it appears 62 times, which typically it appears once in the file name and once in the object name. So that means we've got 31 images of this target. Let's take a look at one. I'm going to scroll down. As I scroll down, you'll see, I know it was cloudy last night, so I'm trying to go to a night when it was less. Oh, there's some. And there's a bunch of them. Okay. So one way to sometimes guess whether it's going to be a good image before even seeing the image is to look in this right-hand column. And the number of kilobytes of information is a little bit of a hint as to how good an image it is. The higher that number, the better the signal probably is in the image. And so I'm going down to this image right here, which says 125, and I'm going to try for that. So there it is. And somewhere in this field, supposedly, is a comet. So let's drag the FITS file over to our JS9 window, and we'll see if we can find that comet. Let's see. We're going to bring the high brightness value down. Oh, and bring the, if I move my cursor in the background, again, it's in the 340s, that the brightness value of the background sky that you want to kind of look dark for better contrast. So I'm going to set my low brightness limit at that 340 value. And I don't know if any of you, I happen to know where it is, so, but you might be able to find it. I'll give you a moment to look. And right there is the comet in the field. And over the next few nights, that comet actually is going to move through the field of view. So anyway, I just wanted to demonstrate using the MicroObservatory image directory, and also the fact that we are starting a new process of identifying targets of opportunity to tell the YouthAstroNet community about. And if you have a target that's not on the request list, but you want your students decide they want an image of it, we could also put that in the targets of opportunity list, and you can use the MicroObservatory image to go get it. So, all right. Let me move my image. Again, and try that log scaling. And there you see it. But that log scaling really enhances the background dimness too. But now you can start to see that comet's tail. And Erica recently discovered that a really good scale to use for objects that are dim, that doesn't also caused this strange pixelation in the background is this A sin H scaling. We were trying to figure out a use for that, and I think this comet is a good one. So this, you can really start to see the tail. You can see the head of the comet there, and actually if I zoom, you can see there that we start to have the comet tail in there. All right, so that's a quick refresher on some features of JS9, and I think right now I wanted to go back and point out, oh, I don't think I brought this up. Let's see. I wanted to, if you're trying to remember kind of the basics of using the JS9 image processor in the YouthAstroNet educator portal, remember that you have all the curriculum and implementation materials, and inside the curricula, you'll find Introduction to Image Processing. And recently, Erica has added an illustrated introduction to image processing. So rather than using a video tutorial, there's an illustrated PDF, which I'll open right here. And you can use that. It's just a few pages, kind of gives you the basics of what I just did on screen. So how to find the low pixel value in the background, how to use the high brightness value, how to log scale to bring out dim images, and how to use the color palette. So that's a nice resource in the curriculum activities. Again, that was in the educators portal under curricula in the Introduction to Image Processing folder. So illustrated image processing, and remember, using the image processing tool frequently is one of the indicators for students who develop increased STEM interest during their YouthAstroNet program. So we encourage you to give kids lots of experience experimenting with that. A new activity that we're about to introduce into the curriculum materials is an activity called Portrait of the Universe. And that activity encourages students as a group to take lots of images. And here, down here, I have a collection of images students might have taken from galaxies to the moon, to the Orion Nebula, star clusters, nebula. Here's Jupiter. Here's tiny little Saturn. And there's a student thought sheet that asks questions, that asks students to think about questions about each of their images. So in an image of stars, the sheet asks, why do stars appear only as tiny dots and not larger disks like our sun? And so it's really prompting kids to look at their image and think about what are the things they observe in the image and why. So the fact that stars appear as dots because they're so far away. Here's a tough one. Why are some of the dots wider than others? Are those stars larger? And the answer to that is tough because often the larger dots are not actually larger stars, but they're brighter stars. And so sort of prompting kids to think about that. To go along with the Portrait of the Universe thought questions, there is a resource also in the curriculum materials called Cosmic Cast of Characters, and I have just one page from it here, which just has some notes for surveying the universe to give students a little bit of background about these different categories of objects. What's the difference between a galaxy and a nebula, a spiral galaxy and a irregular galaxy. So just to give them some, a little bit of background. That, this activity starts getting kids asking questions, and then the extension to doing Portrait of the Universe is to ask students to pursue some project of their own interest. So if you want to focus on having kids investigate some area of astronomy, whether it's moons of Jupiter or moon phases or life cycle of stars, this is one of the activities that's a good introduction to those astronomy topics. But the other thing you can focus on with YouthAstroNet is understanding the instrument that they're using, because all scientists who make observations use instruments, and they have to understand their instrument in order to also understand what they're looking at. So we have a number of activities around understanding the robotic telescopes that the students are using in this project. And so I just wanted to do some refresher of some of those activities. One of them is the pixel to picture activity, in which students use beams to represent photons. They put beams in their hands above the egg carton, and so this would be 2 sources of light, and then they count the number of beams represents the pixel value, which also represents the amount of photons or the brightness coming from that object in the sky. And here you can see these 2 girls translating from the number of counts in each pixel in their detector to a visualized image of that, which is what you're doing when you're using JS9. JS9 is basically taking the counts that were in each grid each pixel in the grid of the detector, and coloring depending on the some sort of paint by number scheme and the value. That activity again is in where is it here? Investigating the technical world, again in the educators portal under curriculum resources, and pixel to picture is this unit 7. Okay. The next activity to understand the student's telescope is an activity called Kinesthetic Telescope, and we talked during the online training about the value of having kids move and make model certain processes using their own bodies, and that helps them understand things. And in this activity, the copy of it is on the right of the slide. Students represent different parts of the process of a telescope capturing light from an object in space. So in this image over here, these kids back here are the object in space. We have a couple of photons who actually seem to be racing at the speed of light here, coming from those, and we have an object over here. So this is an educator who actually simplified the activity for her students. She just represented the objects in space emitting photons, and then she's the detector here, and each student ends up I think the photons from the object on just off the screen on the right are X's, and the photons from these kids are O's. So she shows how their photons wound up at the detector. So this activity, when it's a little more complicated, kids represent the aperture or the opening of the telescope, and a bigger opening lets more photons through. Other students represent the mirror that reflects the photons back towards the detector. And other kids can represent the shutter. Now, once students have an understanding of the robotic telescope and that they're using, they can actually practice engineering skills that are involved in building such a system. The MicroObservatory robotic telescopes were actually custom built here at the Center for Astrophysics, and there were lots of different subsystems that engineers had to build, and you have the opportunity to build those yourself in some of the resources that we have available. So wanted to remind folks that we have these classroom set kits of little bits that you can actually borrow. There's a sign up for resources on the educator portal, and I think we ship those out for a period of up to 3 weeks or 2 weeks.
2 weeks with some
2 weeks with some
buffer on either end.
Negotiability on that. So we send them to you. There's a whole set of curriculum design engineering challenges, again, in those curriculum resources. And I want to show you some examples, again, to refresh your memory of the little bits challenges I have here. I'm going to try, let's see, there we go. That's not bad. Okay, this is a set of circuits using these little bits, and I'm going to turn on all the circuits here. Oh, here's some things happening. Let's see, let me get them all on. Okay, so right now, if you look closely, you can see there's the light sensor here. There's this, you can see I'm moving this slider right here. Oops, maybe I'm moving this slider. There we go. And it's changing the altitude of the telescope, see? Which is changing where the telescope is pointing. There's little motors that turn the telescope. And this light sensor is attached to a readout. So it's like a pixel in the telescope, and you can see if I cover it up, the readout is going down to 1. I don't know if you can see that, or 0 here. If I take my hand off, it's now at 23. It's probably hard to see. Actually, if you pin the image, if you, in fact, if I stop, actually, why don't I stop sharing? Pardon? I can stop sharing for a moment. There we go. There we go. So there's the motor that uses the control. And then here's another motor that controls a shutter. This is a shutter that might cover the light sensor for a 60-second exposure and then uncover it. So students have the ability to design subsystems of the telescope using these little bits. All right. Oh, thank you. All right, so share the screen. The other resource that you can borrow from us actually is a set of laptops. We have a number of programs that don't have quite enough computers or a computer room for the students. We actually have sets of up, I think we have 2 boxes that, you know, you can get 12, 18, or 24 laptops shipped to you for borrowing for up to a couple of weeks. And again, you can use those to run your YouthAstroNet program or to be able to allow students to have 1-to-1 or 2-to-1 computing. So those are resources you should know about. And then the next resource I want to make sure everyone knows about is our mentors, our STEM role models. And we have several dozen scientists, grad students, observatory staff who are interested in answering questions and answers from your students using the online forums on their YouthAstroNet accounts. And we think we've got evidence that for students who have an active conversation with scientists, that they really express an increased interest in science. So we encourage you to do that. Erica will set you up with a personal mentor for your group of YouthAstroNet students. Down here, you see Joe Hora, who has been assigned to a number of classrooms, and in this, you can also request an actual Zoom video conference with a STEM mentor. And again, requesting that is done through on the educator's portal. There's a place to request a live interaction with a scientist or with project staff, with any of us, or with a scientist who studies a particular topic that your students are interested in, and you can set that up. Also on the portal, we have, for about 24 of those folks, we have online bios of scientists who study astronomy, are engineers, and science communicators as well are on there. So I encourage you to take advantage of the STEM mentors as another resource. So I think at this point, that is the set of resources we wanted to remind you of. But the main thing is are we still doing office hours?
Not at the moment.
Not at the moment, okay.
I'm always available.
Right. If you have follow-up, you have specific questions you want, you can always, remember, just email Erica or ask on the educator portal. Let us know you need some help, and we can schedule a personal tutorial to help get you back on track so that you know what to do with your students. I guess I want to ask now if anyone has questions. I'm going to stop the